Hello friends, welcome to channel study guide. So friends, as you know, we are working on the RRB JEE electronics previous year question papers. Okay, and we are solving each and every session questions with the each and every explanation. So in our first set, we are going to solve the 26th of August first shift. If you want to hear it in Hindi version, you already can go to our description box or in the channel videos. There you can find the 26th of August first shift Hindi version solution also. But some of the candidates who tells us that they requires the Hindi version, they require the English version, we are uploading the version for them. Okay, but the solution on the both of the version are similar. Okay, but a lot of people who are following our channel are found that they have some difficulties to understand the Hindi, so I have done the videos for them in the English version. Okay, so let us see what are the questions here. Okay, the first question is depletion layer is found in. What is depletion layer? You already know. In any, whenever a PN type material is formed, okay, whenever is a PN type material is formed, this is the P and this is the N. In the P type material, what we found that the holes are the majority carriers, and N type material, electrons are the majority carriers. Here the holes are the majority carriers, here the electrons are the majority carriers, and when they are connected, okay, by the technology, okay, this means fabricated, not back to back connection, fabricated, what will happen, the majority carriers, due to the concentration difference, what happens, the electrons are move in this direction and the holes are move in this direction. Okay, so in the boundary region they are immobile, the holes and the electrons combine. Okay, the holes and the electrons combine and they form the immobile ions in this boundary layer. Okay, this is the boundary. And if the doping level is low, if the doping concentration is very low, that means the width of this depletion layer is going to increase. If the doping level decreases, width going to be increased. Okay, the width increases. So mainly the depletion layer can be found in the diode, because a diode has a PN junction. Intrinsic semiconductor or any N type semiconductor or any P type semiconductor, we cannot found this depletion layer. Why? Because due to the fact that they has no PN junction. Okay, so option C will be the correct answer. Let us move to the next question. Let us see what is the question is. So in the next question, the energy asks that the energy band in a semiconductor. Now let us see what is the energy band, and we can found we have two energy bands actually. The one is the conduction band and one is the valence band. Okay, conduction band, valence band. Okay, and electron can flow the current when they are in the conduction band. Okay, now whenever in metal the conduction and the valence band are overlapping each other, okay, they are overlap, but in the semiconductor there is a difference, and this in semiconductor the difference is almost 1 electron volt around. Okay, but if it is for insulator, it will be around 10 to 15 electron volt, and maybe much higher than that. Okay, and maybe much higher than that. Okay, so energy band in the insulator is 10 to 15 electron volt, whereas for semiconductor it will be order of 1 electron volt. So this will be the answer. Okay, option D will be the answer. Let us move to the next question. You know about the bipolar junction transistor, I hope. BJT stands for, it was an easy question for the JEE level because the previously the pattern was different. Okay, so one is a base, this is the collector, and this is the emitter, and this is the NPN transistor, and we call it BJT because it is a bipolar junction transistor. Okay, later in our theory we will study the bipolar junction transistor in a far broad way. Okay, the hexadecimal equivalent of the decimal number 210. Okay, 210. Okay, this is, what is this? This is the decimal number 210 and base 10 to, I have to convert it to the base 16, right? Okay, one fundamental things I let you know, that if I move any number from the decimal number system, the process is very easy. We have to know what is the base of the unknown. Here the unknown number is in the base of 16. Okay, if I want to move it to the 8 decimal, if I move it to the base 15, base 14, base 13, base 12, okay, any base I can go. Any base I can go from the decimal. The most easy process is I have to divide it by the base where I am going, but while I am moving. Now I have to divide it by the 16. Now let us divide it by 16. I divided 16, 16 1, 16 50, 3 into 16 48. So remainder is the 2. I have to write the remainder over here. Now I have to write, okay, now let us again divide it by 16. Now can the 13 can be divided by the 16? No, I suppose no, because 13 is the lower than the 16, so it will be fraction. Okay, it will be fraction. Now in hexadecimal system we cannot write such number 13 because we already know A is 10, B is 11, C is 12 and D is 13, like that. So I can replace this 13 by D. So I have to take this lower to higher. If I move from lower to higher, the unknown value will be D2. By this method you can transfer any hexadecimal number, any decimal number into hexadecimal number. Okay, move to the next question. Operational amplifier has the input impedance of infinite because it has no loading effect. It has a one inverting terminal, one non-inverting terminal. Okay, and this is the output terminal. If I make it 1 2 3, it has practically infinite input impedance because it has no loading, so it has no loading effect. So the correct answer will be infinity. Okay, move us to the next question. Theoretically a bridge rectifier, okay, a bridge rectifier has a maximum efficiency of theoretically 81.2%. okay, you have to remember this value because in your competitive examination you cannot always derive this values in the examination hall. It will require you some time. So what I will tell you that you have to remember some of the datas. Okay, and you have to remember that theoretically the maximum value will be 81.2%, whereas practically it will be less than 81.2%. Avalanche breakdown primarily dependent on the phenomenon of avalanche breakdown primarily depend. The difference between the avalanche breakdown and the Jenner breakdown depend on the doping level. Okay, mainly the doping level. They depend on the doping level. If I move to theoretically, okay, they depend practically on the doping level. But here the railway does not given the answer doping. The RRB has given the answer recombination. Okay, because avalanche breakdown primarily dependent, I would not say this is the primary dependence, I would say this is the secondary dependent. Okay, primary dependent would be on the doping. Okay, though the railway has given the answer option D. What is the UJT? UJT already I have tell you earlier. UJT, this is a base 2, this is base 1 and this is the emitter. Okay, now UJT has uni-junction transistor. What is UJT? UJT has uni-junction transistor, and this uni-junction transistor has only one PN junction. Okay, it's already telling us that it has one PN junction. Uni junction, one junction. Uni means one, uni junction. Okay, Now the binary representation of 99.25. You can see this is 99.25 and base is decimal. Okay, you have to know the base is decimal. Earlier in this video I have already told you, if you want to grow from the binary, sorry, you want to go to decimal to any base, decimal to any base, what you will find, you can find that 99, you have to divide it by which base I'm going to base 2, so I have to divide it by 2. So if I divide it by 4998, so remainder will be 1. In the right hand side I have to write the remainder. Okay, if I divide it by 2, it will be 24, remainder 1. If I divide it by 2, 12, no remainder, 0. If I divide it by 2, it will be 6, 0 remainder, 2, remainder will be okay, 6 to 6, and this is also 0. Next, if I divide it by 2, the remainder will be 1. Okay, now what I have to move, I have to move from low to high. So if I move from the low to high, 1 1 0 0 0 1 1. Okay, what I have done, I have done the left part of the decimal point, I have done the on the left part of the decimal point, but the right part, okay, is not the same process. Or what is the rules for the right part? You have to multiply it by 2. I have divided it by 2, here I have to multiply it by 2. So what will be answer? 0.50. Okay, now integer part is 0 and there is a decimal part, so until there is a decimal part I have to multiply. Okay, so if I multiply the 0.50 into 2, I found that 1.00. Now the integer part is 1, but there is no decimal part. But if there is no decimal part, I have to stop over there. Stop over there means 0, 25. 25 means 50, 0.50 into 2, 1.0. So now in the left, for the right hand part, I have to move top to bottom. So in the top I have 0, in the bottom I have 1. So I have to write the integer part for the after the decimal places. So here I write decimal 2. So this is the correct answer. I have not given here all the options, I have only given the correct answer. In the left hand part you have to divide it by 2, write the remainder and go from below to upward. And for the right hand side, for the part of the decimal part, what you have to multiply it by 2, and I have to take the integer but from top to bottom. Here you go bottom to top, here you go from top to bottom. Okay, this is the rules, and this rule you have to remember. Now what is the next question? Next question, x is a binary variable. If x is a binary variable, then what will be the Boolean expression for the x equals to 1? They have asked. Now in Boolean algebra we know there can be two values, one is 0 and the other is 1. Now 0 plus 1, that will be always 1, and if I take that x equals to 1, 1 plus 1, that is always 1. That is a logic 1, this is also logic 1. Now so what will happen, if x plus 1 in the Boolean algebra, it will always be substitute by 1. So the correct answer will be option B. Okay, this would be option B, will be the correct answer in the Boolean algebra. The 2's complement of the binary number. Okay, this is the binary number given to me and I have to found the 2's complement. First we have to found the 1's complement. How can we find the 1's complement? I have to convert the 1 into zeros. Okay, and I have to convert the 1's into zeros and zeros into 1's. Okay, here I have converted this 1 into 0. Okay, let us write let us write the number first, right? 1 1 0 0 1 0 0 0 1. So if I want to convert it, so it will be 0 1 1 1 0 1 1 0 0. Already I have found the ones complement. Next, what I have to do, I have to add 1 for the twos complement. Now I have add 1, adding 1, it will be 1 1 1 1. Here is a 3 0 1 2 3. Here's 2 0 3 0 2 0 1. Okay, this is 1 0 1. Okay, this is 1. This is also 1. This is also 1. And this is okay, 0 0 1 1 1. So this is my answer, and this is not given in the option, right? Okay, actually the data given in the question was something mistaken. Okay, because if you see here is 1 2 3 4 5 6 7 8, and there I was written 9 datas. Okay, there was only mistake. So if I make the correction on the question, the process will be same whatever I have told you, but the datas are different. Now this is my original number. I have to make ones complement of it. So 1 will be 0, 0 will be 1, 0 will be 1, 1 will be 0, 0 will be 1, 0 will be 1, 1 will be 0, and 1 will be 0. Now what I have to do, I have to make this twos complement. So I have to add 1. Now add 1 on this number. If you add 1, you can find that this is with 0 plus 1 1. This is 1. This is also 1. This is 0. This is 1. This is sorry. So this will be 1. This will be 1. This will be 1, and this will be this. Sorry, this will be 1. This is 1. This is 0. This is 0. Now. So this is the answer what we have found. Okay, and you can tally with that this answer is in the option B. What I am done, I am telling you again that I have to make this 1 into zeros, 1 to zeros, and then I have to add 1 with the ones complement. This is the ones complement of the number, and I have to add 1. 1 plus 0 1 1. This is 1, this is 0, this is 1, this is 1, this is 0, this is 0. So 0 0 1 1 0 1 1, and you can find this option lies in the option B. Okay, thank you for watching the video. If you want to see more videos of the 26th of August, second shift, third shift, and the other shifts, okay, and if you are watching the video, please subscribe to our channel and press the bell icon. Whenever you found the new videos are uploaded, then you can suddenly get the notification. Thank you.